Here we go. All right, guys. Day 24. Our do now is going to start with having you identify whether this sample here that I described, is it random or biased? And then I want you to explain why. So can somebody read that situation to me and give me an explanation of if you think it's random or biased?
Candy wants to know, Candy wants to know what the most popular item is in the vending machine. So she told the students in the math room about what their favorite vending machine item is.
All right. So she wants to know what the most popular item is in the vending machine. We're talking about the one out in the hall. So she asks the students in the math room what their favorite vending machine item is. What do we think, guys? Is that random or is that biased?
Biased.
Okay, biased. Why is that biased? Right. Right. We are not the only people eating out of the vending machine. We are not going to get a true, accurate answer unless we get a larger pool of people that we're choosing from. Absolutely, guys. Okay, sounds like everybody understood that one. Any questions about number one? Okay, if not, let's go ahead and move on to number 2. This is where we're going to be drawing the line of best fit for the data that is shown on this scatter plot I gave you. And then we're going to practice writing the equation like we did last unit, y equals mx plus b, for that line. So first of all, whenever you are writing the line of best fit, what is it that you're trying to do? I'm going to grab my ruler. What do you guys think? Right. You want to find the line that is going to be as close to all those points as possible. You want it to be the one that fits the best. That's why it's called the line of best fit. So let's get our ruler on here. And it looks like I've got a little bit of variance here. My data zigzags a little. So we don't want to just do it under it or over it. We want it to be somewhere right in the middle. Your guys' lines look similar to this? About like that?
Yes, ma'am.
All right. So I'm going to go ahead and draw my line here. And again, it's not going to be exact, because we're not finding the line of best fit with the formula. We're just doing an estimate here. So this might not be the perfect line, but it's a close one. Okay, so we've got a line. Now we need to write the equation. So let's think back to last unit. We had 3 steps for solving equations. Do you guys remember what those 3 steps are? Yep, so step 1 is we're finding m, we're finding our slope. Then what? Yep, we're finding our y-intercept, or b. So find b, and then write the equation. Not so bad, guys. So what can we do here with this information to write our equation? What should we do first? Say it again. Pick 2, like pick 2 coordinates, you mean? Yeah, absolutely. Let's pick 2 coordinates. So what are some coordinates that you guys picked? Okay, Jasmine, can you say what yours was again?
85 and 110.
Okay, so 85 for the x, and then 110 for the y, and what's the other one you chose? 90 and 100?
Yep.
Okay, so 90, 100. Okay, so that's one set of coordinates we could use. Anybody want to give another set we could use? I want to see how similar. Okay, 55 and 200. Perfect, 90, 100. All right, did anybody do something similar or different from those?
I did 70, 90.
So you did 70.
70 for my X and Y, 90 for my Y, 140 for my X, and 100 for my Y.
Okay, so let's look for a second. You said 70 for your x, and whenever we follow 70 up to our line, it's going to be somewhere in between 140 and 160. So what did you say was the value with 70 you put? Did you say 90?
No, because the line it goes 140 goes across.
Yeah.
So,
Yeah, for it to be 90, it would have to be all the way down here. So let's fix that point. We'll do 70 what? What do you want to do for this? We want to pick one, like, so for example, we're finding the equation of this purple line here. Is this point on the line? It's not. So we don't want to include that. We would want to find the value that is on the line. So I'll go 70 up to here, and that's about 55-ish. It doesn't have to be perfect, but are we okay with 70 and 155? All right, let's do that. Oh, good. Well, guys, yeah, absolutely. Ask questions. So whenever we're writing the equation, remember, we are writing the equation of the line that we found, not the data. So you don't want to use coordinates that aren't touching your line. Now, if you drew your line differently and this one is touching your line, then use it, absolutely. But that, I'm glad you guys asked that. You want to either use coordinates that are touching your line or come up with new coordinates that are touching your line. Okay, so Tasha, what was the other point you said?
I did 70, 155, and then I did 80, and I think that was 110.
80, and so 110 would be right here. Does 110 touch your line? You might have angled it more.
No, yeah. That's the second line. No, I don't.
Okay, so let's go up a little more. What would it be instead of 110, maybe?
115 to the middle.
Yeah, let's do about 115. That works.
Yep.
Okay, so we did, what was that, 80 and 115? Okay, 80, 115. Okay, so we've got a couple of different coordinate sets to work with here. We could use any of them, okay? Now let's see what kind of slopes we're going to get. We're going to use our slope formula. Let me grab a separate sheet. You guys are welcome to do work on the back of your papers. I, however, don't want it to bleed through, so I'm going to get a sticky note. And let's just look at some examples of what slopes we might get. So first of all, what is the slope formula? You guys remember?
Y2.
Uh-huh.
Y1.
Y2 minus Y1
Yes.
over what?
X2 minus X.
Good, X2 minus X1. So let's try this first set here. I'll label them. I've got X1, X2. I'll zoom in even more. Let me get this a little bit easier to see for you guys. Okay, and then my Y1 and Y2. Okay. So we are going to plug these coordinates into our slope formula, and that'll be m is equal to our y's. So I've got 100 for y2 minus y1, which is 110, over x2, and in this case it's 90, minus, yes?
Does it matter which coordinates you write up there first? As in, if we did 90 over 100 and then 85, 110?
Do you mean like, could I do 110 minus 100 and then 85 minus 90?
Yeah.
Yes, that is a great question. So I'm going to explain that for everybody real quick. Whenever you are using your coordinates and plugging it into your slope formula, normally we write it as y2 minus y1 over x2 minus x1. But it doesn't actually matter what order you put them in as long as you're consistent with the order. So what if I did y1 minus y2 instead? I could do that as long as I do the same thing with my x's, x1 minus x2. So if putting the 2 first feels strange, you can always do 85 minus 90 and 110 minus 100 instead. The key is being consistent with it though. You will get the same answer. All right, so we did our y2 minus y1, and our x2 is 90 minus x1 is 85. And what are we going to get for our y's on top, our rise? 100 minus 110. What is that? It'll be 10. Is it positive or negative? Negative 10. We're taking away more than we have. Start with 100 and we're subtracting 110. All right. Now we have 90 minus 85. 5. Okay. Do we need to simplify? We do. What is 10 divided by 5?
2.
2. Negative 2. Okay, I got negative 2 as my slope. Did you guys get something similar? Same thing? Or a little different? 1 2/3? Yeah, that's super close. 1 2/3, I would take that. As long as it's negative. Now we remember, we see how our line is pointing downwards. That means we've got a negative slope, a negative correlation.
I got on 2 in the synthetic coordinates.
Uh-huh.
I got negative 100 over 35.
Negative 100 over 35.
Yeah.
So let's write that out. Can we simplify?
Yeah, I mean, I could divide 100 by 20.
Well, can you divide 35 by 20 also?
That's what I was trying to find one way to divide, and then I divide both.
Well, here's a trick that I always like to remember. Any number that ends in a 0 or a 5, we can take them divided by 5.
Okay.
So why don't we try that? Let's do 100 divided by 5. 35 divided by 5. That's going to give us negative 20 over 7. Okay, and it looks like we can't simplify any further, so let's see what that would be as a decimal. Negative 20 divided by 7. See how close that is to negative 2. Okay, so it looks like you just got a slightly steeper one. Negative 20 divided by 7 is negative 2.857, and it keeps going on forever.
Yeah, mine is yours.
Yes.
So can we simplify that to 2.56?
This one right here?
Yeah.
So we have 2.85.
I mean, not 56. 86.
Yes, we could. We absolutely could, because the next number is 7. If we wanted to, we could say, okay, I've got my negative 2.8, and then 57 rounds up to 60, or if I'm looking at 5, does it go up or down? If it was more than 5 on the next decimal place, which it is, it's 7, you would round up to 6. Now, I'm not grading you on rounding, so it's okay if you don't do that perfectly. But if you notice, all of these answers are going to be very similar, usually within about 1. So we might get something as low as negative 1. We might get something, we might get something as high as negative 1. We might get something as low as negative 3. But as long as they're similar, which they are, they're in the same realm. Okay, so that was a long-winded way to explain slope. But we found our M. Let's go with negative 2, just because it's right in between the values that I heard people say. If you put a different slope, that's fine. You don't have to change it to negative 2, as long as it's a similar number. So there's our M. How do we find B?
Take one of the coordinates.
Yep.
Just write out the y coordinate equals your slope times your x coordinate.
Yeah, absolutely. We're just going to take our slope that we found and we're going to pick one of these coordinates to plug into our equation. So I like 90 and 100. I don't know about you guys, but that one looks nice. So let's do that. If I'm using y equals mx, that's really going to be hard for you guys to read. Let me get a different color. Okay, so I've got y equals m, what's m? -2 or whatever m you found, times x plus b. Okay, and then we said we're going to put in this coordinate 90, 100. You could use a different point as well, but for the example I'm going to use this one. So what goes in my y spot? 100, good. 100 equals -2 times x, what's my x? 90 plus b. Okay, now we just got to solve what is -2 times 90. Good. -180. We'll bring everything down. We've got 100 equals -180 plus b. And what's next? Add 180 to both sides. We're going to get a larger b than I was expecting. Okay, 280 equals b. All right, so we found our b. Did you guys get similar numbers for b? Good. What numbers did you guys get? I'm just curious.
Actually, kind of funny. Actually, I said it without 1 2/3. I actually got 2 2/3.
Huh?
So that's around 0.6 extra compared to the normal slope. And I got 340, which is just 60 over.
Right. Pretty close. Pretty close.
I thought that was nice.
So I got 280. You might have answers up to 400 or down to 100. It's going to be a little varied since we're not doing it exact. But you should get a similar answer there. And what's our equation now that we have m and b?
Y equals -2 times,
Ah.
2x plus 280.
Perfect. And again, your answer might look slightly different, but I got y equals -2x plus 280. And remember, our b is our y-intercept, and we can kind of reason with this graph. I can see that as my arrow goes up higher, it's not going to be an exact hit, but it goes 200, 220, 240, 260. It might be a little off, but I might not have drawn it perfectly. But it looks like that's correct, guys. Okay, that was a lot. Any questions about that process? We're going to take a break from that for a while. But before we do, any questions? Okay, are we ready to check out the rest of them? I just have 2 more questions about this line. I want to know, is this a positive correlation or a negative correlation?
Negative.
Negative. If the slope is negative, or if the correlation, the points are going downward, that is negative, absolutely. And last but not least, correlation or causation?
Both.
Ooh, is it both?
I would say that hotter temperatures are causing people to buy less hot coffee.
So let's think about it. This is where it gets really, really tricky. Causation is one that I think is one of the most difficult to really understand, and I think you can explain your case both ways, absolutely, because when you look at the data, you can see it is very obvious that when the temperature rises, when it gets hotter, they sell less coffee every time. You're not seeing any exceptions to that. However, we want to know, is the temperature the cause of their sales changing? Is the temperature the reason? Is it forcing people to buy less coffee? Is it forcing people to buy more coffee? Or is it more of a situational thing? Are there external factors? What do we think? Let's talk about it.
I just don't think there's enough information to like, I gotta say for causation, yeah, there's probably not enough information to say for sure because it's very
Right.
broad, and hot coffee, higher temperatures, that's kind of a broad thing.
Right,
And
right.
there's people that drink coffee all year long, it doesn't
Right.
matter. Like, my mom, my mom drank it constantly, or my grandma, so.
Right.
It didn't matter if it was cold, hot.
Exactly. Yes, Chance?
I think that the temperatures just put stress on the body that make it to where it's uncomfortable to drink it.
Yes, absolutely. There's so many things to consider, guys. And just like what Star said, there's probably some people that the temperature doesn't affect them. I drink hot coffee every morning, whether it's 100 degrees or 20 degrees. I just like hot coffee. And then there's some people that will follow this trend and only get it when it's cooler outside. It's really tough to say. It's tough to say. This is where statistics gets a little blurry lined, because you could argue either side, and I think you could probably convince me on either way. So, whenever it comes to this question, correlation or causation, especially when we get to quizzes, as long as you're able to thoroughly explain and back up your answer, that's what I'm looking for, is that explanation and that reasoning behind it. Just remember that causation means that it directly affects and directly is the reason for the change that we are seeing. Okay, do we have any questions about our do now? All right, guys, we are going to finally move on. That was a long do now. Let me show you what we're going to do today. So, here's our topics. We are going to review quickly what we've learned so far in Unit 2. And then we're going to introduce a few new things. So for this little review, we're just going to talk for a moment. First of all, we learned about samples. We talked about the difference between a random sample versus a biased sample. We talked about correlation versus causation. And we talked about finding the line of best fit and writing the equation for it. So we've done all three of these things just now in our do now example. Is there any kind of looming questions or confusion that comes with any of these three topics here? How do we feel about these three topics? If you could give me a thumbs up for I feel good, thumbs in the middle for it's okay, thumbs down for I'm totally lost. Okay, I'm seeing a couple of different answers here. Gotcha. Okay, so if we are totally lost, first of all, we need to ask ourselves, were you here for all the lessons? If you weren't, go back and watch them. They are all on YouTube. That will catch you up. The other thing to do is please come and talk to me and tell me I'm not a mind reader. I want to help you guys succeed, but I cannot do that without your cooperation. I can only do so much as a teacher. And I'm happy to answer questions. Really, I cannot read minds, and I will never be frustrated with any question. That is what I'm here for, is to try to do my best to answer. Okay. So basically, quick little overview of each of these. Our samples. Guys, what is the difference between a random sample and a biased sample? Star?
A random sample is like if we was to check out the entire school.
Mm-hmm.
A bias is if we just stayed in-house here in the math room.
Yeah, so a difference there might be surveying the whole school versus surveying just the people in this room. So the big key difference between a random sample and a biased sample is that in a random sample, every person has an equal chance of being picked. Every person does. So if our population includes the school, for the sample to be random, every single student in this school needs to have an equal chance of being picked. Yes?
So can there be like a random poll or something, a random sample that has like a stipulation in it? Like if there's a rule in it or a stipulation can still be considered random?
Yeah, there could be. So like for example, what if we wanted to find data regarding, I don't know, everybody's favorite ice cream flavor, but we only wanted to include our class as the population. So this would mean that it's not going to include any other students, but it could still be random as long as every person in this room has an equal chance of being picked. So it kind of depends on what you're defining as your population or the people included in the survey, the sample.
Would the poll end up being what everyone in this class's favorite ice cream is then?
It could be, absolutely. Or maybe I would draw names out of a hat, you know, say I'm going to pick 5 names and there's more than 5 of you, so not all of you will be picked, but you have an equal chance because I'm not looking, you know. Okay, does that make sense?
I'm just saying, it's like if the statistic where you're trying to find out like everybody in the school,
Yes.
but you're the poll, but you're including everybody in this class, you could take the poll, would that still be considered random?
So if it was supposed to be a statistic that we're finding that's based on the whole school and we only survey people in this room, that would be biased. Because then we are the only ones that have a chance of being picked. Everybody else gets excluded. All right, good. Okay, any other questions about random versus biased samples? Happy to talk about it as much as we need to. How about correlation versus causation?
I'm kind of
A little confused on that one? Yeah, those are confusing.
Sorry.
Go ahead.
So correlation versus causation. So here's what I have in my head with it. So without having to complete details down. So correlation versus causation. One is the reason, what's the reason behind it rising or the reason for it falling.
Mm-hmm.
And the other is whether that's the actual reason for it happening.
Yes.
Whether it's because of, okay. I like it.
So let me just pull up our notes from Thursday about correlation and causation. So correlation is just the relationship between two variables, meaning if there's a positive correlation here, it just means that whenever one of those variables is getting bigger, the other one also gets bigger. It doesn't necessarily mean that they have any relation to each other in any way. It just means that they increase at the same time. Now, if there's a negative correlation, this is still a type of correlation. It just means that as one variable gets larger, this other one gets smaller, so it's going to move downwards. As long as it stays consistent, they are correlated. It doesn't mean that these are causing each other to change. It just means that they do change at the same time. So correlation just means that they have similar movement patterns, and it's a consistent movement pattern. So here's where the difference comes in. Causation means that one of the variables is directly causing the other one to change. Meaning if I change one all of a sudden, the other one is also suddenly going to change in the same way. So for example, here was a couple of examples we talked about. Like shoe size and reading ability. What we notice is that as a child's shoe size gets bigger, their reading ability also increases. They get better at reading when their shoes get bigger. So this is correlated. They both grow at the same rate, but this is not causation. If a child has a larger shoe, that does not automatically mean that they can read better. It doesn't. Just like if a child were to, I don't know, get in an accident and lose their feet, Now they got little tiny shoes. Does that mean they can't read anymore? No, these do not cause each other to change. They only have correlation because they tend to move in the same direction. And that kind of invisible variable would be that the child is growing and getting older. When a child grows, its shoes usually get bigger. When a child grows, their reading level usually gets better. Okay, here's one that would be causation. Plant growth and watering frequency. So somebody did a study and noticed that plants that are watered more frequently, they tend to grow taller and healthier. So we want to think about the fact that, let's say for more water, the plant does better. So there's a correlation. They're increasing at similar rates. And we know that this is causation because the frequency at which a plant is watered, meaning if I water it more or if I water it less, and let's just assume in this example the plant likes water and it's not going to drown it. We're going to keep it simple for this. But that amount of water we give it will directly affect the plant. If I water it less or if I stop watering it, its growth is going to eventually also stop because of the water change. So that's why this one is causation. The water causes the plant to change. Okay, does that make sense, you guys? Does that clarify it a little bit? Okay, any other questions about that? All right, if not, let's look at what we're doing other than that. We got to do some...
I have one more question about random bias.
Yeah.
That's an easier way to, or I should say an easy way to identify the difference would be if the poll or the sample has a lot of rules of stipulation, it's not going to be random. Like in the title.
Probably,
It
yes.
says something like you said about the snack aisle, be at the snack aisle.
Right.
At a certain time during the day.
The main takeaway that you want to kind of get from random versus biased is just in a random sample, every person has the same chance of being picked. So like at the grocery store, if I wanted to know what every person that shops there, what their favorite snack is, if I only come at one single time at 7 p.m. on a Tuesday, they said, not everybody is going to be there at that time. So that's why that one would not be random. It would be biased. We could make it random if we were to extend that survey, extend that poll, say over a couple of weeks, give everybody a chance to come in over more time. But yeah, it's just thinking, does every person have an equal chance of being picked? Okay. And we just did the line of best fit and we wrote that equation. Do we feel okay about that process? Okay. We're going to move on, guys. Today, this will be in the note packet I gave you. We are going to introduce bar graphs and histograms. And then if there's time, we're going to learn how to draw a box and whisker plot. So, I know, I love the box and whisker plot. I think it's so goofy compared to everything else. But let's go ahead and write about the difference between bar graphs and histograms. You'll see there is an example of both in your notes that I gave you. However, I'm going to have us practice drawing little mini versions of these first, just because I think it's good to know how we construct each of them. So, bar graphs. I'm going to make two little lines here. Here's bar graph versus histograms. First of all, how many of you have heard of either of these, bar graphs and histograms? Know what a bar graph is? Okay. Anybody know what a histogram is?
No.
Brand new word for some of us?
Is it a graph based on history?
Not quite, but that's a really good guess. A graph based on history? Maybe.
Like things that we,
You guys will see in just a minute here. It's really, really similar to a bar graph. So, first of all, a bar graph, we use that to compare groups or categories, for example, just to show visually the difference in size. So used to compare groups or categories. And a histogram is used to show the distribution of data, basically to see how many fall into a certain interval or category. And that will make a little more sense if we look at the histogram. But I'm going to write this definition first, or the use. Used to display the distribution, and that's also like the spread of the data. And that's separated over a few different kinds of intervals. Alright, so if you like writing definitions, I'll give you a minute to copy those down, and we're going to practice making just little minis of each of these.
So is a histogram basically like a spreadsheet?
Super similar to a spreadsheet,
Okay.
yes, very similar. I'll show you kind of the difference here in a minute. So let's, for example, I'm going to give you some data. Let's say I want to compare the eye color of boys versus girls. So I'm going to say we're looking at blue eyes, we're looking at green eyes, we're looking at brown eyes. And we are comparing the difference between males and females. So I'm going to write M for males, F for females. So I'm going to create a little chart of my data here. So before I fill out this data, I want to make sure everybody understands how we read this. Whatever number I put in this first box in the top left-hand corner, that is touching the blue and it's touching the M for male. So this is the number of males with blue eyes. Directly under it, it would be the number of females with blue eyes. And then we move to the next column. The top row is going to be the males with green eyes. Bottom is females with green eyes, and so on. So let me give you some numbers, and then we're going to make a graph together. So male blue eyes, we're going to have 15. And female blue eyes, we're going to have 10. Male green eyes will have 5. And then female green eyes, we're going to have 10 again. And then male brown eyes will be 20. And female brown eyes will be 15. Okay. So here's how we're going to label our graph, our bar graph. First of all, I'm going to write a title, and it's going to be eye color of males versus females. Okay. And then on a bar graph, we're going to do the same thing as we do with a scatter plot. We'll have an x-axis and a y-axis. I'll label these as well. And then we are going to label our different categories. Now, this is a bar graph where we're comparing eye colors and genders, and we're counting the amount of each. So we're actually going to be combining two of the variables on one axis here. Now, I want to give you guys a little bit of peace of mind. I'm not going to be having you construct complicated bar graphs for your quiz. You're just going to be answering questions about a bar graph I give you. I just think it's important to know how to see where all these things are coming from so that whenever you are asked questions about them, it makes a little more sense. Okay, so here's where I'm going to use some colors. I'm going to do, this will be brown, green, and blue. Actually, this blue. And we're going to put the eye color on the x-axis. So, eye color. And I'm going to have in this little section my blue eyes. So here's how we create the sections. We're going to do one little area here where we're going to put the bars for both the males and the females. So let me show you this first with the blue eyes so that the rest of the graph makes some sense. So let's look at our chart here. Under blue eyes, how many males have blue eyes? 15. And then how many females? 10. Okay, what's the highest number on this whole chart? 20 is the highest number. So let's go ahead and make a little, what's it called? A scale here. Just so that we can start making our bars. We'll start at 0, 5, 10, 15, 20 is what I'm going to do. Because 20 is our top value. And we label our y-axis the count. That just means how many. Just like that. Okay, so for blue eyes, males had 15, so I am going to start within this little area I created, and I'm going to draw a line up to 15 and bring it down about like that. And for boys, I am going to make them orange so I can compare. And then females, how many did we say have blue eyes? 10. Good. So for the blue eyes category, my female bar is also going to be touching my male bar right here. And that is how I'm going to do the first one. There's my blue eyes. So female, I'll pick a different color. I'll do, I don't know, pink. And guys, if you want to use any colors, I have a whole big bin full of markers and highlighters and all sorts of stuff over on that shelf. You're welcome to use them. Okay, so there's our blue. Next, we want to do our green eyes. Now, our next category, we don't want the bars to touch anymore. We're starting a new color. So I'm going to create a whole new area right here and label it green. And then I'm just going to look and see how many green eyes for the males and the females. So it looks like males 5 have green eyes. So I'll draw a bar up to number 5 right here. And females have 10. So I'll draw a bar up to 10. And it's not perfect, but you guys get the idea. All right. Is everybody to that point? Anybody need a little extra time? Anybody confused about any of these steps so far? Okay. Once you've got green, we're going to also plot our brown eyes. So I'll make a brown section over here finally. Brown. And males have 20 brown. Big section. And 15 females. Okay. And once you have completed your bar graph, it should look something like this. The only thing that we have left to do is to label the bars themselves so that we know which one is males and which one is females. And there's a couple ways that we could do that. So whenever you guys get done drawing that, if you look at the page that I gave you in the notes where I showed you a bar graph that looks like this, you see I made a little key right here where I just did a color code box. So I showed you that this was math students, this was history students. That's one way you could do it. You could create a color-coded key, or you could write another bar above the categories right here under the bars where I labeled this side is history, this side is math, this side history, this side math. So on this one, I could either write male and female under the bars, or in this case, I would prefer to make a key. So I'm going to just make 2 little boxes and color them in. So I'm going to write males, females. And then I'll color my boxes just like this. Say it again. If you don't have 2 different colors, first of all, I do have a ton of markers you can use over there. Second of all, if you don't want to use colors, this is something my high school teacher taught me. You could make 1 stripes and 1, I don't know, polka dots, and then that could be your key. Or you could color one in completely, or you could get creative with it, make it a little pretty, little graph, have fun with it, you know. Just whatever you end up doing, make sure that you label it in some way so I can tell what you're showing. All right. Okay, so there's our bar graph. That's what that looks like. Anybody still working on theirs? Any questions about the bar graph? You guys feel decently comfortable about making one? Okay, awesome. Let's look at a histogram. And again, you will have an example of a histogram in your note packet I gave you. So here is where I am going to give you some more data, and this time I'm going to give you, it'll be test scores. So let's see. We're going to use intervals, and by intervals I basically am showing you groups of information, quantitative So let me just show you what that means instead of trying to explain it. On the test, I'm going to see how many students got between a 0 and a 20%. That's our first interval. I'll say 5 students did. How many students got between 21 and 40%? I'll say 2. How many got between 41 and 60%? Let's say 7. How many got between 61 and 80%? And that's going to be 10. And then how many students got 81 to 100? And that will be 17. Okay, so here's our data. So it's test scores. And you can either call it the count or the frequency. Basically, how often the score was in this range of data. Okay. I'll give you a minute to get that kind of copied. And I'm going to go ahead and title. Histograms are super easy to title because we just write down the word histogram in the name. So for this histogram, I'm going to call it Histogram of Test Scores. Okay, and same as the bar graph, we're going to create an X and a Y axis. And give yourself room. I didn't give myself very much. And I'm going to do the same scale for my y-axis as I did for the bar graph. I'm going to count by 5s and go up to 20 because my highest number is 17 right here. So I know I'm not going to have to count any higher than 17 when I'm drawing my histogram. So I'll do 5, 10, 15, 20. And just like a bar graph, you can either write count on this side, or what you'll probably see most often is the word frequency. And that just means how often that score appeared. Alright, and on our x-axis, we're going to be putting those ranges of test scores. So there's going to be 1, 2, 3, 4, 5 categories here that we're comparing. So I'm going to make 5 little tick marks and separate my data. So from 0 to 20%, 21, 40, 41, 60, 61 to 80, and 81% to 100. So I just counted by 20s for my intervals. Alright, so now we have our x-axis labeled. And I'm going to call this test scores. Alright, I'll slow down for a second. You guys are doing awesome. Making y'all write so much today. That's why I made those printed notes. I can't imagine having you do this about 4 times. Okay. Now, the big difference between a histogram and a bar graph is where the bars are spaced. So if you'll notice in the pass out I gave you, bar graphs have space in between their bars. Histograms do not. You want them all touching, just like this. So what we're going to do is just plot our data on this histogram. We're going to draw bars, and we're going to make sure that everything is touching. So I'll start with my, yes? It sure is, guys. Thank you. I normally have an alarm, and I guess I forgot to today. It is lunchtime, okay? Go ahead and enjoy lunch. Come back at 12:30 if you can. Got a little more I want to teach you today. Little more. But yes, you guys enjoy lunch. I'm going to pause this recording. Okay, so lunch is over. Let's finish our histogram. So let's look at our first interval here. We have students that scored between 0% and 20%. How many students are there if we look up at our data set? How many got 0 to 20? 5. So what I'll do is I'm going to draw a bar that goes up to 5. And that's going to be my first bar on my histogram. Okay, next range we have 21% to 40%. How many got that score? 2. So we are going by 5s here, so we're going to put it somewhere below the midpoint between 0 and 5. So let's go about here-ish. And like I said, we want our bars to touch. So we'll just draw a line right there, and there's our second bar. Okay, how about our next interval, 41% to 60%? How many? 7. Good. So I'm going to draw my bar going up to about 7. Here's 10, 9, 8, 7, somewhere in the middle there. And down. Okay, how many for 61 to 80%? 10. So we are going to draw a bar up to 10 right here. All right. And finally, 81% to 100%. How many's there? 17. So we're going to draw our bar going somewhere in between 15 and 20, right about in the middle. Right here-ish. There we go. All right, so whenever you've drawn all your bars for your histogram, we're not really comparing different groups within each category, so we don't need to color code anything. You can color it in if you just like to do that, but this would be a completed histogram. All right, I'll give you guys a minute if you need to copy that down. Do we have any questions about histograms and bar graphs before we go on to answer questions about them? Okay. Like I said, I'll give you guys a second to get caught up. Pause this. All right, so that was just our second page of notes. We talked about what we're doing today, bar graphs, histograms. We made one of each. Now, if you'll go to the packet I gave you, on the second page, you should see something that looks just like this. We're going to talk about how we read or how we use a bar graph. Now that we know how they are made and where the numbers come from, let's put it into practice here. So, this is a bar graph. of ice cream flavor preference by classroom subject. So what that means is we polled students who are in math classes, and we polled students who are in history classes, and we asked them what their favorite ice cream flavors are between these three options. We got chocolate, vanilla, cookies, and cream. So whenever we look at the graph, the bar graph, remember all we're doing is looking down here. I see the subject, my history students, or over here in the key, we've got those in orange, and the flavor is listed right below. So just by looking at this first little section here, about how many history students like chocolate ice cream? About 20. Good. Okay, so we're reading it right. How about math students?
15.
About 15. Perfect. Okay, so let's go through and just make sure we can answer all these questions. And if we can, we're going to be moving on real quick. So, question number 1 says, which subject preferred vanilla ice cream more? Oh, history or math? Let's see. Vanilla right here. History, we got 10. Math, we've got 15. Yep, so math had more students, so we would say math preferred vanilla. Math students. Good. All right. Now let's look at number 2. I want you to answer which flavor of ice cream is most preferred by math students. Cookies and cream. Yes. How many chose that?
35.
Looks like about 35. Good. So for that question, what are we going to write?
Cookies and cream.
Cookies and cream.
Yeah.
Good. All right. Number 3. Which flavor is least preferred by history students?
Vanilla.
Vanilla. Yep, I see history in orange, and vanilla's got the smallest bar. So we're going to say vanilla is their least favorite one. Okay. Let's try number 4. The only thing I want to ask you here at the end is how many math students are represented here total? So, ooh, let's see.
I got 55.
Okay, guys, tell me how you found those numbers. Somebody tell me. Natasha?
Well,
35. Go ahead.
okay. Actually, the most, whichever one, in the math class,
Mm-hmm.
it shows 35.
Yep, so we got 35 right here.
35, yeah. That's where the green bar stops at. We didn't do history yet, do we? History started though.
So we've got 30 for the most ice cream flavor here, absolutely. Now we want to know how many students are there overall, just in math. We'll start with math.
You would just add all of them, so you got 35.
Yeah, so it looks like right here there's 35 that voted for cookies and cream. How many voted for vanilla?
15.
15. How many voted for chocolate?
15.
Also 15. So if every student can only vote once, that means that we just add these 3 numbers together, and that's going to give us our total number of students that voted.
65. Good job, Bob.
Yes.
Good job.
So 35 plus 30. 65 math students. And let's check out history. How many have we got in each category? I heard 30 for cookies and cream,
10.
10 for vanilla, and 20 for chocolate. So 20 plus 10 is 30, plus 30 is 60. So we've got 60 history
It's
students.
crazy how all my second numbers stayed the same, but the first number I got wrong.
What are you talking about?
I got it right now after doing it because
Oh, good.
I only did the 35 and 30.
Right,
When you said that,
right.
I was like, oh, that does make sense to do that. But then all my second numbers, like the first one I had 35, the second one I had 30. And then when you just said that with the correction, not everything is 65 and 60, it's still got the 5 and the 0.
Right. I know it's super tempting to just look at the biggest bar and think, oh, that's all of them. It's like, no, they're all spread out. We got to count every bar. Right. Well, good. All right. Any questions about reading a bar graph? You feel like we could do okay reading these on our own? Good. Okay, let's flip to the next page in your packet. We are going to practice reading a histogram. So, here is a histogram, and this is not accurate data. I seriously was at my computer last night. It was like 1 in the morning, and I was trying to figure out I'm not kidding, I don't even want to admit how long I spent on it. I was trying to figure out where I could find the data, the real data, for the ages of all of our students. Because I just thought it would be cool to see the real spread of our different ages. So I had to guess. Now, if I am able to actually get my hands on it, I might have to just talk to somebody on the staff. I bet someone knows how to do it. We'll make a real histogram so everybody can see the spread, because I don't know, I find that interesting. So, we've made a fake one. We'll just pretend this is real. What I did is I have made the intervals, all of the different student age groups that exist. Now, this first age group from 18 to 19, that one is a little small. All the other groups are done by tens, but this is different just because our enrollment age is 18 and up. So, you know, I can't put 10 to 19. We don't have 10-year-olds here, except for in the little scholars area. So, what we've got here is all the different age groups. We've got our frequency on the side, and what's that frequency going to tell us on our histogram? The count, yeah. What's the count telling us? What are we counting?
How many individuals in that area?
Yes. How many individuals, how many students fall into each category, each interval? So if I were to read this right here, how many 18 to 19-year-olds are there? 8. Good. Absolutely, because that bar goes right over to 8. So let's talk about some of these questions. Okay. Number 1, which age group contains the most students? 20s. Good. So you could either write 20 to 29, or you could write 20s. So that's got the most students in it. Most students are in their 20s. Okay, which age group contains the least students? 70s. How many?
Right there is 1.
1. That's right. 1. So we got 1 person in their 70s.
Everybody looks so nice though, you can't tell who.
Right. Oh. Okay, so we've got numbers 1 and 2. Number 3. How many more students are in their 20s versus their 30s?
5 more.
Ooh, I hear 2 different answers, 5 and 10. Let's look.
So 5.
How many students are in their 20s? 16.
The other one's 11.
Yep, and 30s have 11. So how can we solve this?
I don't know, I just looked at it, I got
Subtract
4.
11 from 16.
Yes, we could take 16 and subtract 11. That's going to give us our difference of how many more. We could also just count. We could say, all right, it goes from here up to 16. So there's 1, 2, 3, 4, 5. The difference is 5 students. That's all right. That's all right. Okay, so how many more students are there? 5.
It's so weird 'cause I had the right numbers and everything.
Right.
In the lab, I'm like, oh, here's my math.
I know it. Silly mistakes. We all make them. We all make them.
The silly mistakes.
All right. Any questions about histograms? How do we feel?
Excellent.
Good. Okay, guys. We're going to learn one last thing today. This is the last thing we're going to learn about statistics. The rest of this is going to be review from here on out. And then we'll be moving on to the next unit, y'all. I know.
The last unit was super long.
I know. This one, it's crazy.
Yes.
All right. I need you to start a new page in your notes. This is something very important. Now, with the bar graphs and the histograms, I wanted you to practice making one, just so you could understand where the numbers come from, where the bars come from. However, this next thing I'm going to introduce to you, I want you to really take notes on step by step how to make one of these, because on your quiz, I will give you data and ask you to make one. Okay? I know, I'm so mean.
Real quick, did you remember to take attendance?
Yes, I did. I did it during lunch.
I'm not here.
I know. All right, so I'm going to have you title your notes. This is going to be a step-by-step guide. How to construct, that means make. We're making the box and whisker plot. A box, and that's really what it's called. A box and whisker plot.
I like that name.
I know it, like a little kitty cat. All right. So there are about 5 steps to doing this. First of all, I'm going to show you what a box and whisker plot looks like. And I'll label it for you. So you will be given a number line of some sort. And it really just depends on what the problem is, but this is just for your scale, for example. Let me give you a good example. We'll pay attention to that scale later, but your box and whisker plot is going to look like this. You'll have a little end here. There's your whisker. And then there's going to be a box. With a line in the middle somewhere. And there's one more whisker like this. So this is what your box and whisker plot is going to look like. It's going to be 2 long whiskers with a box in the middle, and each part of this box and whisker plot has a very specific purpose and must be labeled a very specific way. So let me give you those labels. So this point right here, you will line it up on your number line that you're given with whatever your data says is the smallest value. So this is your minimum, your smallest value. Right here. And if this is your minimum, what do you think the far right one is?
Maximum.
Your maximum. Good. So this will be your largest value. All right. Next, we have what we call quartiles. Quartiles. So quartiles are just separations in your data. I'm not going to get too complex with the definition of quartile here, but we have 3 of them. Quartile 1 falls on this line, and we just call it Q1. Quartile 2, also known as the median. We'll learn about that today. This is Q2. And last but not least, we've got Q3. So this is the setup of a box and whisker plot. And we're going to run through an example together and make sure we understand every step. I'm going to give you a nice, organized, written out guide that I want you to copy. Okay. So we are going to be starting off with a given set of data. So I'm going to give you guys an example list. We're going to go with that similar data to what we just did with the histogram here. I'm going to write out a bunch of student ages, and we're going to make a box and whisker plot for it. So I'm going to label my data student ages. And I'm going to write kind of small here so I can fit everything on. I kind of want all of my data to fit in one nice line. So I've got 18, 19, 21, 23, 25, 27, 31, 36, 39, 43, 47, 52, 56, 59, 65, 72. Long list, I know. Normally I won't give you this large of a data set. This is a very large one. All right. So whenever we are making a box and whisker plot, I'm going to show you exactly how it's going to look on your quiz eventually. This is a sneak peek of your practice quiz. I'll show you. You'll be given data. I'll tell you to identify the minimum, the maximum, the quartiles, and this is the number line that you'll be given. So let's do that with this. And I'm going to teach you each step by step, guys. All right, so step 1, I'll have you write this as well. We want to identify the minimum and the maximum. Now, actually, back up real quick. Back up. Step 1 really is to make sure that your numbers are in order from least to greatest. I forgot that because I already put this one in order for you. But your numbers have to be in order from least to greatest. So like on your quiz here one day, these numbers are not in order. You'll have to put them in order first. Okay, so step 1, put numbers in order. Least to greatest. Okay, and our data is in order. We're good there. Now step 2 is going to be to find your minimum and maximum. So step 2, identify minimum and maximum. So if we're looking here at our big set of data, I'm going to draw little boundary lines around it. What number is my minimum? 18. So I'm going to circle that. There's my minimum. And what number is my maximum? 72. So I know that whenever I draw my box and my whiskers, this line that goes out to the minimum is going to line up with 18 on my number line. And my maximum value, that line is going to match up with wherever 72 is on the number line. And we'll do that here in a bit. So we've identified our minimum and our maximum. Step 3, I'm going to write this one in orange. What we want to do for step 3 is to find the median. And that's not as scary as it sounds. Doesn't even involve much math, actually. And your median is Q2, right up here, your second quartile. So let me show you how we do that. So does anybody know, first of all, what median is? Middle, yes. So it's like in statistics, sometimes we hear about mean, median, mode, average. There's all sorts of different things where we add numbers together, divide, find, average numbers. Median does not involve any of that. We are really just going to be counting from the outside to the inside and seeing which number is smack in the middle. Now, what if there's 2 numbers in the middle?
36 and 39.
Let's look. So I like to just cross them off one by one. I got 1872, 1965, 2159, 2356, 2552, 27, 47, 31, 43, 36, 39. This is my median, somewhere in the middle. So since there wasn't a number that we landed on, we have an even number of data points here. We need to find what number is directly right smack in the middle of 36 and 39. How could we do that?
There would still not be because it'd be 37 and 38.
Okay, so let's see. If we go up 1 from 36, we've got 37. If we go down 1 from 39, we've got 38. What's in between these two numbers? 37.5. We can use halves here. We can use halves. So our median is whatever is in between. So in between 36 and 39, we're going to count on our number line. I'll make a little number line to show you. Okay, so I've got 36, 37, 38, 39. This was the 2 points we had, these two. So let's keep looking for what's next in the middle. We moved in 1, and it looks like we're going to land right in between 37 and 38, which is 37.5. You're allowed to use halves for your median. All right.
Let me ask you a question.
Yeah.
Could we have just added 36 and 39 and then divided both of them?
Yes, you could have. There's 2 different ways we can do it. So the other way is we see that there's 36 and 39 in the middle. So we could do what Jeremiah said. I could do 36 plus 39 divided by 2. And whatever that answer is my median. So go ahead and do that on your calculator real quick. See if you get the same answer. You should get 37.5. You guys get that?
Yeah.
Good. Okay, so let's make a note under step 3 so that we're not looking back at these later and we're confused. So the median is the number in the middle of the entire data set. We'd say if there are two middle numbers, we can either count towards the middle until we find that half number, or we can add them together and divide by 2. Either one will get you there. Okay, so we've got some options for step 3. Okay. Now, before we move any further, is anybody confused about step 3? I know this is a tricky part, and I'm happy to answer questions about it before we move on. I don't want anybody getting overwhelmed. I know it's new stuff. Is everybody okay with trying out step 4? Okay, so step 4 is we're going to be finding Q1, which is right here. So step 4, find Q1, and what Q1 is it is the median of the lower half of values. So see how we drew a line here in between 36 and 39? Now we're going to be using only these numbers, 18 to 36, to find our Q1. We're going to find the median of this group of numbers, the lower numbers. So to do that, we need to find what number's in the middle. And I'm going to start by crossing them off. 18 and 36, 19 and 31, 21 and 27, 23 and 25. It's somewhere in between 23 and 25. What number's in between there? 23, then 24, then 25. We don't need a half number for this one. This one, there is a nice pretty number right in the middle. So 24 would be our Q1. Okay, so find Q1, and I'm going to put in parentheses, it is the median of the lower half of data. And one more step. We got to find Q3, which is right over here. So if finding Q1 was the median of the lower half of data, what do you think we'll do to find Q3?
For the higher half.
Yeah, exactly. We're just finding the median 3 times. That's all we're doing. We're just counting and looking for the number in the middle for 3 different areas. So Q3 is the median of the upper half of data. So we're going to do the same thing. We're just going to be counting off numbers until we find our value for each. So 39 and 72, 43, 65, 47, 59, 52, 56. Okay, we got to find what number is in between 52 and 56. I'm going to count 54. Did anyone get something different?
No, that's what I got.
That's what you got? Good deal. Everybody get 54? Okay, awesome. So guys, all we need to do now is label. We're gonna fill out all the information we found, and then we're gonna draw it. So what was our minimum that we found?
24.
Our minimum of the whole
Oh,
data
18.
set. Yes, 18. So 18 is where this line would need to fall. What was our maximum? 72. Good. And then what was Q1?
24.
24. Q2, or our median?
37.5.
37.5. Good. And Q3, what was that?
54.
54. Very good. So now that we have all these numbers, here's what we would do. On your practice quiz and your actual quiz, you'll be given something like this, where you have the values to line your box plot up with. In this case, I'm going to have us draw it together. So if our smallest number is 18 and our biggest is 72, why don't we go from like 10 to 80? So I'm going to have you draw a long line at the bottom of your page. And let me think. This would be 40, 80. I maybe should have used a ruler here to make it more accurate. Let's see. Well, there's good enough there. So 40, 60, 80, makes that 50, 70, and it doesn't have to be perfect. Okay, so I've got this here. And you could label even more if you wanted to, but I'm just gonna do it by 5s here. Okay. All right, does everybody have somewhat of a number line made? Okay, so here's what I'm gonna do. I'm gonna take my paper and kind of fold it so that I can see what my numbers are up against my graph, because I didn't make my paper too well. Okay, this is just so that we can all see it better. So what I'm going to be doing here is I want to line up each point with my number line. So first I start with my minimum. Where on my number line should I be drawing my minimum?
20.
By 20.
Yeah, it's at 18. So here's 15, here's 20, somewhere in there. So I'm going to just do this. There's my minimum. 18. Okay. And then where's my Q1?
20, 20, and 25. Right by 25.
Yeah, so my Q1 is 24. So I want that to come right before 25. So maybe here. Close enough. There's Q1. And since I already have my minimum to my Q1, I could go ahead and draw this line for my whisker. You can wait till the end if you want, but I just don't want to forget, so I'm going to go ahead and draw it. Okay, next line we should make, we just did minimum, we did Q1, and then comes what? Q2, or the median. So where should that be on my number line? Yeah, so here's 30, 35, 40, somewhere between 35 and 40. So let's just put it right about here. All right. So we've got our Q2, our median, and where should Q3 fall? Yep, 54, just before 55, in between 50 and 60. So here's 55. I'm going to put it a little bit before that. Okay, so now I've got my Q1, my Q2, and my Q3. So I can connect and make my box. All right. So there's that. And where does my maximum value go?
72.
Yes, at 72. It's going to go a little bit above the 70, but below 75. So I'll say right about here. And I'm just going to connect my whisker to my box. And this is our box and whisker plot, guys. Not so bad. It's kind of a lengthy process, I'll give you that. But if you follow your steps and just keep it organized, it's not so bad. It's really not. Okay. So whenever we have a box and whisker plot, this is used for a similar purpose as a histogram. Whenever we see a histogram, it's typically done to show the distribution of data, so that we can see that, oh, there's more people that fall in this range, or this range, or this range. But what this is showing us, our box and whisker plot, it's just showing our distribution in a different format. So what's happening here is the lower 25% of my data is being shown right here. And as you can see, this is a teeny little area, just like this is a slightly smaller bar than what comes next. Then the middle 50% of my data is in here, and the rest of it, the other 25%, is represented over here. Now, box and whisker plots, you don't see these very often out in the real world. You don't. It's one of those very statistical things that I've yet to see where it's helpful, because in my point of view, at least, I think this helps me understand data a little better than this. This has its place and its purpose. I just don't have the best example to give you at the moment. So if anybody does have a good example for a box and whisker plot, let me know sometime. Okay. That's what we're learning today. That's it. So before I give you an exit ticket, how are we feeling about that? I know that was kind of a lot. We doing okay? Good, 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 good. All right, guys, let's do your exit ticket. So this is day 24. And I'm going to have you make a box and whisker plot. I know. It's going to be a smaller set of data, though. It won't take this long.
I actually think that was the easiest one that I went to.
Really? Well, good. I do, I think. Let me look. Unless I left it. Nope, here it is.
Thank you. I appreciate it.
Yeah, no problem. Okay, so I am going to give you some data, and I want you to construct a box and whisker plot. How about, and I'm not even going to tell you what it means. I'm just going to give you numbers. Okay. Before you make your box and whisker plot, please remember the step 1 that we did not have to do with the last set of data. Your numbers have to be in order. If they are not, it's going to mess it up real bad. So I'm going to give you boxes to fill out for each thing. I want you to tell me the minimum, the maximum, Q1, Q2, and Q3. And I'll go ahead and give you a scale, like a number line. I'm going to be working on this with you guys because I got to make an answer key.